The video will cover section 5.3, double angle, power reducing, and half angle formulas. Now, some of the formulas on this section you will have to memorize, and others I will provide to you, okay? This three here, you will memorize. Now, let's see, okay, not the tangent. To be honest, I don't know tangent. But this two, guys, is very important that you memorize, okay? Why? Because you will need them in calculus. I promise you, you will. And so they're like the most common ones. But let's say that you forget those two, right, on the test. Well, I am going to provide you with the formulas from 5.2, which are here on the dry erase board. And so if you forget the double angle, you'll be able to derive the other two. So let's see if you guys got the same. So in this case, we have sine of theta plus theta. So I will use the formula for double angle, which will be on the dry erase board, formula number 3. So that will be sine of theta times cosine of theta plus cosine of theta times sine of theta. What happens here is that we're not talking about two different angles. They are the same angle, right? So what's going to happen here is that both quantities are the same, right? If we use the commutative property and rewrite this one instead, sine theta first and cosine theta second, it will be exactly the same as this one, right? So we have two of those, so if we add them, we will have 2 times the sine of theta times the cosine of theta, which is this formula right here. Okay, so the next one, of course, we're going to do cosine of theta plus theta. So I'm going to look at formula number 1, so that will be the cosine of the first angle, which is theta, times the cosine of the second angle, which is also theta, and then minus the sine of the first angle, which is theta, times the cosine, I'm sorry, not the cosine, but the sine of theta. So if you multiply cosine times cosine, what do you guys get?
Cosine squared theta.
Cosine squared theta. And if you multiply sine times sine,
Sine squared theta.
okay. And so that's what we have right here. Now, I'm going to tell you, and you will see in the following slides, this formula, the one for cosine, it has different variations. And those variations come from the Pythagorean theorem, okay? But we'll get to those in a minute. Now, the one for tangent, so I'm going to need your help, guys, with this one. So this is, okay, so what is it again?
It's tangent theta plus tangent, I guess it'd be theta, over 1 minus tangent theta, tangent theta. Tangent theta.
Plus?
No, it's multiplying.
Times. Like that? Okay, so if we do that, we will get on the top, if we combine those two quantities, we have 2 of those, so 2 times tangent theta. And then on the bottom, we will have 1 minus tangent squared theta. Is that what we have up here?
Yes.
Yes. Okay, wonderful. So do you guys see, you know, I will not give you those formulas. But if you, except for tangent, or I might not ask you a question with tangent. But this two, you really need to memorize. And I promise you that you will need them one day. Yeah. And don't call me. If you're taking a test, and then you forget the double angle, don't think about calling me and asking me for it, because I told you to memorize it. All right. So right here, what we're going to do is find the exact value of those angles, okay, by using those formulas that we had. So can I please have a volunteer to write them on the board? Can you write okay? Legibly? No. Dima. On that one, yeah, because I still want to keep those.
These ones?
No, so we're going to write the ones on the first slide.
Oh, okay.
Those 3, just write them. You can erase all that, all the stuff on the left. Okay, so you guys can see that for those formulas, they use sine of theta, right? They also use cosine of theta, and they also use tangent of theta. So for that reason, we're going to have to find those three values first. So we're going to use the information given. We have the sine of theta is 5 over 13. At this point, we should already know that the sine is given the y coordinate and the hypotenuse or the radius, right? Yes? Okay. So then we also know that the angle is in quadrant 2, so that's important. So the angle is in quadrant 2. We are going to have 1, 2, 3, 4, 5. So 5 for the y, and then the hypotenuse is 13. So I'm going to estimate something right here. Okay. So right there, actually, it will be from here too. This is theta, and this will be theta prime. All right, so the points are, not the points, let's do a triangle. So the opposite side, or the y value is 5, the hypotenuse is 13, and of course we have to find this missing side right here, right? The one adjacent to the angle. So we're going to use Pythagorean theorem, of course, and we're not finding the hypotenuse, we're finding a side, so let's call it a. And a is going to be the square root of c squared minus b squared. So that's going to be 13 squared minus 5 squared. And that will be 169 minus 25. And that is equal to 144. And we take the square root of that, will be 12. 12 or negative 12. So what should we use here, guys? 12 or negative 12? Negative 12, because we're in the second quadrant, right? And so the x values are negative. All right, so now that we have all of that, let's find what the sine, the cosine, and the tangent will be. So the sine, we already have it. It is 5 over 13. The cosine is going to be adjacent, so that will be negative 12. Thank you, Nima. Over 13. And the tangent is going to be opposite over adjacent, so that will be 5 over 12. What am I missing, guys?
Negative.
Negative. So remember, in quadrant 2, both cosine and tangent should be negative, okay? So now that we have all of that, we're going to use the formulas to answer the question. So for the very first one, which is the sine of 2 theta, so we're going to use that formula that says 2 times sine of theta cosine theta. And so what we're going to do is substitute stuff in here. So why don't you guys do it? Oh, listen. Okay, so right here, example 1, we have the answer for part A, and we discussed that that cannot be reduced. And so what we did was use the formula and then substitute. So we substituted the fractions, multiply straight across numerators and denominators. And for this one here, we have formula. We substituted. We had to square the trigonometric ratios that we have here. And then we subtracted them because they had the same denominator. We got that. And now for tangent of 2 theta, so I will need to use 2 times the value of tangent of theta, which is negative 5 over 12. And then on the bottom, it will be 1 minus negative 5 over 12 squared. Yeah, well, here 2 times negative 5, yes. It's negative 10 divided by 12. On the bottom, I have 1 minus, and I need to square this fraction here, so that will be positive 25 over 144. Now here, this is a complex fraction, because it is like a fraction within a fraction, right? So there are several ways to solve them. For instance, we could do this. Negative 10 over 12 over, right here we'll have 144. So that means that this one will be 144 over 144, and then minus 25. So we could do that. We'll get negative 10 over 12 over 119 over 144. And then we do, we multiply. So that will be negative 10 times 144. I lost it, sorry. Okay, so we had negative 10 times 144, and then we're going to multiply 12 times 119. So what we could do here is the 12 is the same as 12 squared, right? I'm sorry, the 144 is the same as 12 squared. So right here I can cancel this 12 with this 12, and so I will just have negative 10 times 12. Divided by 119, so this will be negative 120 over 119. Okay, that's one way to do it. Let me show you guys another one to do that you could use for this type of fractions. So you have something like negative 10 over 12, and then here it was 1 minus 25 over 144. If you were to consider all the denominators here, the denominators are 12, 1, and 144. What would be the lowest common denominator?
12.
I'm sorry.
The greatest.
I get those confused. GCD and LCM. Okay, so lowest common multiple, or the denominator. So it's not 12,
124.
144.
Wait. The one we went with greatest common.
You know what? It is not any of this. It's actually the LCD.
Yeah. Jesus Christ.
Least common denominator. I just get all three of this mixed up. GCD or GCF. That's true. GCF is greatest common factor, LCM is least common multiple, and then LCD is least common denominator. So that's what we need. There's no greatest common denominator. We always want the least. Yes. So what we do is we multiply everything by 144 over 144. Okay, get ready to be surprised. The LCD is 144, right? So I have 144 over 1. This is a 1. 144 over 1. Now let's see what's going to happen. Negative 10 times 144 is negative 1,440. And then 12 times 1 is just 12. And then right here, you will say 144 times 1 is 144. 144 times negative 25 is that. And then 1 over 144 is just 144. Oops, sorry. Okay. Is he happening? Yes. All right. Now, what's going to happen here is that everything is going to be divided, okay? So what is negative 1,440 divided by 12? That is negative 120. What is 144 divided by 1? 144. And here I can cancel that, so it will have minus 25. So this is minus 120 over 119. That's more work.
This is why they invented calculators.
So that's why, and this is why most of the students who study science and engineering don't come from the U.S.
Why?
True stats.
Because they don't use calculators.
Exactly. Because we are the only country who sadly pushes the use of a calculator. sometimes it's elementary school.
I'm curious with the greatest.
You could Google it. Most of the students, college students, who are in STEM fields, engineering and science, are from other countries. Why? Because they don't whine and complain about everything. Because no, I'm not done. Because they don't get a free education. They actually have to work for it.
Maybe it's also because
It's a lot
they
They have higher standards as well. Yes. In fact, when you go to YouTube, well, you come from another college, but professors at UTEP, like U.S. students are down here, students from Mexico are here, and then students from everywhere else are.
Miss, don't they have a better education than like US?
Okay, so example 2, what we're going to do is kind of like work this problem backwards. So if you're not very familiar with the formulas yet, but I'll write it down here. So the formula for the tangent of a double angle is 2 times the tangent of the same angle, but not double, divided by 1 minus the tangent square of theta. So if you guys recognize this formula here, it looks pretty much the same as this one, right? What is the only difference? 15. So here it's telling us that theta is equal to 15 degrees. So what will 2 theta be? 30. Right? 2 times 15. So what this formula is telling us is the value of tangent of 2 times 15, or in other words, the tangent of 30 degrees. Okay, and so the tangent of 30 is what, guys? I know it has a square root of 3 somewhere.
Yeah, because it's square root of 3 over 2 over 1 over 2.
Not over 2.
No.
Let's see, the sine of 30 is 1/2, and the cosine is the square root of 3 over 2. So that will be 2 over 2 times the square root of 3, which will be 1 over the square root of 3. So that will be the square root of 3 over 3. Okay, again. Right here, the sine of 30 is 1/2 divided by the cosine of 30, which is the square root of 3 over 2. I use the sandwich rule, so 1 times 2 is 2. 2 times the square root of 3 is here. Then we cancel the 2's. We end up with 1 over the square root of 3. After rationalizing, it will be the square root of 3 over 3. Do you guys know how I got from here to here?
Yeah.
Okay. All right, so if you guys could please answer checkpoint 2. So same idea, you need to figure out what the angle is. Wait, why? What are you guys?
No, I think you did that. No, keep going. Yeah, you did that. I really don't.
Okay, example 2, guys. I'm sorry I forgot to record this part, but what we did, we worked it backwards. So right here, this is the formula for double angle of tangent. So we know that theta is 15 degrees. So then 2 theta will be 30 degrees. So right here, this formula is representing tangent of 2 times 15, which will be tangent of 30 degrees. And if you don't know what the tangent of 30 degrees, if you don't know why is this the square root of 3 over 3, then I will suggest that you take a look at this part right here. You feel free to pause the video so you can analyze it. For the checkpoint 2 is similar to it, but this is the formula for the cosine of a double angle. The angle theta again is 15, so 2 times 15 is 30. And then cosine of 30 is just that. Now moving on, so those 3 are the variations of the cosine of 2 theta. So I'm going to show you how to derive them. So for that, I'm going to use Pythagorean theorem. Pythagorean identity. So right here, if I want to, let's say I want to solve for sine squared theta, that will be 1 minus cosine squared theta. Now going back to the original, let's say I want to solve for cosine. So that will be cosine, not cosine, but cosine squared. So that will be cosine is equal to 1 minus sine squared theta. Are you guys okay with this part? Like, these are just variations of the Pythagorean identity. Are we okay with that? So on this one on top, what I did was I moved sine squared to the right side, so that's why it became negative. Similarly, on this one on the bottom, I moved the positive cosine squared to the right side, and that's why it became negative. Okay, now what I'm going to do with this formula, I'm going to substitute either cosine squared or sine squared with the expressions that I found here. Here and here. Okay, so the first one will be cosine of 2 theta is the same as, instead of cosine squared theta, what should I substitute it with, Lorenzo? So look at what's circle on the highlighter on top. So on the right side of the equal? 1 minus?
1 minus 6 squared.
Sine, not sin.
Who is that?
That's okay. Okay, and then we still have this minus sine squared theta. And so we have 2 of those, right? But they're negative. So if I combine like terms, it will be 1 minus 2 times the sine square of theta. So that's the number 3 right here.
So
Right here.
how would you get
That's what we got. Dima. Numero 3.
if we didn't
This is number 1. This is number 3. Okay, well now let's see.
Wait, a little lost.
Yeah.
You should have done this
More than
longer.
one.
Wait, where did you get the sine squared theta?
Okay, let's start again. Let's start again.
We went and lost the other side.
Okay, I'm gonna start again. Well, I'm sorry, but like, if Dima and Corina are confused, that says I didn't explain it very well. Because not to be sexist or anything, but they're the ones who kind of get it like first. Like it's about speed, not about who's smart. They're the quickest in this class. Okay, I'm not saying they're the smartest. I'm saying they're the quickest.
They're the only ones.
Okay. So we're going to explain again by using the Pythagorean identity how we're going to obtain formula number 2 and number 3. All right? So the Pythagorean identity is sine squared theta plus cosine squared theta is equal to what? To 1. So now, right here, I want to solve for sine squared theta from the original function, okay? So it will be sine squared theta, and then here on the right side I have a 1. And then, Emily, what will happen to this positive cosine squared theta once I move it to the right side? It will be what? Negative. Very good. Right there. So this right here is what we're going to use to substitute sine squared theta. Okay? So let's do that. So this is formula number 1. Are we okay with that? No, don't worry. It's because you told me to do them in order.
Oh, okay. Now I gotta erase it.
Okay, so the first one is there already. Now let's see if we can come up with formula number 2. So what I'm going to do is substitute sine squared theta with that expression on the right side. So it will look like this. cosine squared theta minus, in parentheses, it will be 1 minus cosine squared theta. The quantity that I have right here in the rectangle, okay? That's all I did. I replaced this one with that. Are we okay with that? Okay, now I'm going to simplify it a little bit. Yes. Yes. I'm going to simplify it a little bit, so then it's going to be cosine squared theta minus 1 plus cosine squared theta. So how many cosine squared thetas do we have? 2. So 2 cosine squared theta minus 1. So which formula is that? The second one. Okay, so I did them in order this time. Good. Okay. Now what I want you guys to do, and you're going to do this one on your own, okay? I want you to use the Pythagorean identity and then solve for cosine squared theta. When I say the Pythagorean identity, is this one, okay? Yes. So if you solve for cosine squared using Pythagorean identity, you should have something that looks like this. Cosine squared of theta is the same as 1 minus sine squared theta. Do you guys get that? So that expression right there, we're going to substitute it in place of cosine squared theta, okay? And that is going to give us formula number 3, yes. So this was formula number 2. And let's find number 3. Okay, so let's go for number 3, formula number 3, guys. So I'm going to start from the formula number 1. And now we're going to replace cosine squared theta with this expression right here. So please do that. So instead of cosine squared theta, what am I going to get, Adelina? And then we have another minus sine squared theta here. So we combine those two, so it will be 1 minus 2 times the sine square of theta. And that will be formula number 3. Right here.
Yeah.
I hope so. To be honest, guys, the only formula I knew was that one, but I knew how to derive the other two. So. Okay, so let's take a break. 3 minutes only, okay? Now for example 3, and I believe most of the following examples are just about verifying identities. So to verify this one, I'm going to start on the left side, and I'm going to split the cosine of 3 theta. We're going to say, instead of 3 theta, we're going to call it 2 theta plus theta. And so remember, when we prove an identity, we're trying to prove that the left side is equal to the right side. We could also go from right to left, but we don't know it's called power reducing formula yet. Okay, so from here, let's go ahead and use the formulas that we have for double angle. Now, we do have 3 alternatives, right? We have 3 options. One of them is the one that we have on that dry erase board. It has cosine square and sine square. What we're trying to get only has cosines. You guys notice? So would it be convenient to use that one?
No.
No. So what else could we use? Formula number 2 or number 2? 2. Number 2. Okay. So that formula, is that the one 1 minus?
Extra cosine.
2 cosine. Okay. So the cosine of 2 theta will be 2 cosine squared
Theta
minus 1. Okay. because, okay, let me tell you why we cannot use this. If we were talking about an even angle, like if this was 4 theta, then yes, we could split in like 2 theta, 2 theta. But we're talking about 3 theta, so because of that, I'm going to use the other formula that gives you the cosine of the sum of two angles. So I'm talking about something like this, like what you guys did at the beginning of the lesson on the first slide. Do you guys remember? Yes, the very first slide. So that formula, looking from the dry erase board, was cosine theta I'm sorry. Hi, right. Oh my God. Okay, I'm sorry. Right here, this is like this was alpha and this one is beta. All right? So let's follow the formula now. So it will be cosine of this angle right here, 2 theta, times the cosine of the second angle, which is theta, minus, I'm using this formula here, right, Lorenzo, right here, minus the sine of what? 2 theta, times the sine of what? Theta. And that doesn't take me anywhere, right?
Oh my goodness.
What are we gonna get to?
Yeah.
We're trying to get to this one right here. But what I can do is use the double angle again, here and here. Okay? And that's how we're going to get to that one on the right side. So let's just substitute that one with what we have here. With that part. This one here. Okay? So the cosine of 2 theta right here, I'm going to use this formula. So that will be 2 times cosine squared theta minus 1 times cosine theta minus, and let's use the sine of 2 theta, which you have on the dry erase board over there. So that will be 2 sine theta, cosine theta, and let's not forget we still have sine theta here. Okay, now we're going to multiply. So when we multiply cosine theta times 2 times cosine squared theta, we will get 2 times cosine to what power? Third power theta. Then when we multiply cosine theta times -1, it will be minus cosine theta. Then what we could do here is multiply sine theta times sine theta. So that will be minus 2 sine squared theta cosine theta. Okay, so we missed a couple of steps because I was checking my work with the book, but it is correct, so we were on the right track. So here I'm going to distribute the 2 cosine theta, and then -2, that's important, times negative cosine cube theta, so that will be positive 2 cosine cube theta. Okay, now we just got to combine like terms. How many cosine cube thetas do we have?
2.
2 and 2, so that will be 4. So it's right here and here. So that is 4 cosine cube theta. And right here, cosine theta, how many do we have?
3.
-3. So
Give us a problem.
that identity definitely did not release any endorphins in my brain.
This,
Yes.
is there any real life application?
Oh my God, again. Again.
Yeah, like.
You know what? I'm not gonna spend like the last 10 minutes that we have of class answering your question. How about you do a research project on it?
Oh. Extra credit?
Yeah, on the test.
How many would
I don't know. No extra credit. It's just so that you know. Okay, so remember what we were doing here was proving identities. Okay, we were trying to get from the left side to the right side. So that's what we did. Okay, next slide. We have 3 more formulas, and this I call the power reducing formulas. Those I will provide during the test, so you don't need to memorize them. And of course, you don't want to see how they're derived, right? Okay. So you do not have to memorize. Okay, so we're going to be using those 3 for the next problem. So reducing the power of a trigonometric function. So earlier, Karina was surprised that we had something like cosine to the 3rd power. So in fact, you can have any trigonometric function to any power, okay? And so right here, we're going to reduce cosine to the 4th power. So what we want to do is leave it so it doesn't have powers greater than 1. So the formula that we have is cosine squared of theta. And I'm talking about the formulas from the previous slide, from this one, okay? And that is equal to 1 plus the cosine of 2 theta divided by 2. So that's what we're going to be using here. But the trick is that we're going to have to do it twice. Why do we have to do it twice?
4 power 4.
Power is 4, right? So you reduce it from power 4 to what? So power 2. And then from power 2, we'll reduce it to power 1. Okay, so cosine of the 4th power of x is going to be, I'm going to follow this formula here, guys. So it's going to be 1 plus cosine of what? What do you guys think?
4?
It's going to be 4x or 2 times 2 theta. Not theta, x. I'm sorry. Or simply just 4x.
Doesn't matter if you use X.
Well, if we start with x, that's a great question. If we start with x, we have to continue with x. If we start with theta, we have to continue with theta. And on the test, if you were to give me the answer with a different variable, I will probably not give you full credit. So be careful with that. Yes, you always keep the same variable.
Is theta just like colored version of X?
Yes, but used for angles. So for angles, Greek letters are used for most common ones. Okay, so once we have this one here, I'm going to have to look at the book. Sorry, guys. Oh, that's example 4. Okay, so it's wrong, guys. Sorry. I know, I'm sorry. I didn't prepare. I was having fun yesterday. So you guys know how I feel when you come to class and prepare. Okay, so that's what we should have done. Jesus Christ. You can say it today. You can say it. Okay. So then when we talk about that, it's going to look like this. 1 plus cosine. Like we're going to work it from the inside out. So right now, just try to focus on what's in here. And we're going to substitute it by using this formula. All right? So it will be 1 plus, instead of 2 theta, we'll have 2x. And then on the bottom, we'll have just a 2. But remember, we still have the square here. Yeah. And so what we're going to do now, instead of substituting twice, we're going to do this. 1 plus cosine of 2x squared. So that means that we multiply that by itself, right? And we also do that with the denominator, so 2 squared. Okay. So if we multiply that, it will be 1 times cosine of 2x. So that will be cosine of 2x. Here, 1 times cosine of 2x. Then we multiply, yeah, like you're foiling. So then 1 times 1. So that will be just plus 1. And then we take this one, cosine of 2x times 1. So that will be plus cosine of 2x. Then we multiply cosine of 2x times cosine of 2x. So what would that be? Cosine to what power?
Square.
Square. The angle remains the same, okay? We're not multiplying the angles. So let's reduce it a little bit here, and of course everything over 4, yes. So if we reduce it, we can combine cosine of 2x with cosine of 2x. So how many of those do we have? So 2 cosine of 2x plus 1 plus cosine square of 2x. And if you notice, the 4 is dividing everything. So we're going to divide by 4 every single term. And so what do we get 2 divided by 4, guys? Just 1/2, right? So we could say 1/2 of cosine of 2x. And then we have plus 1/4. And then here we're going to have 1/4 of cosine square of 2x. Are we done? Unfortunately, we're not. Because the requirement was to not have powers greater than 2. So then we have to do this again. So I guess I was partially right. So we're going to have to do the substitution again. Right here. No complaint. Yes? Yeah. So the power cannot be greater than 1. So that's why we'll do it again. So we're going to take this same substitution and use it here. Right here. So, Brianni, right here, remember this because you're going to read it to me, okay? So it is 1/2 of cosine of 2x plus 1/4 plus 1/4, and then what is that quantity?
1 plus cosine of 2x over 2. And did you want this first? So?
Yeah, now in this case, that's when we do the 2 times 2x, so that will be 4x. And over 2. Yes. No, like I was checking the 4x. Yeah. I didn't go over the problems, guys, because, you know, I do have a life, but I also had a meeting during break. I know, your life is to be a student. So, and I am.
Sit down.
And I am a teacher. What do I look like?
You're not actually one.
I am acting like a teacher. Okay, so
Shots being fired.
in this case, we multiply. So 1/2 cosine 2x. No teacher is perfect, okay? I have not met a teacher who doesn't make any mistakes.
No student is perfect.
So even professors with PhD in mathematics, they do make mistakes sometimes, okay? So give me a break. It's not like I make a mistake from this country or out of the country. They all make mistakes, okay? You will see. So yes.
So what would be over 8?
1/8, then 1/4 times this, so it will be cosine of 4x over 8. Now here, we can combine those two. And so that will be 1/2 of cosine of 2x plus, what is 1/4 plus 1/8? 3/8. Very good.
Is there a shortcut to this?
This is the shortcut.
Did we reduce that or no?
Nope, that's it. That's the end of the problem. So don't pack your stuff. Don't pack your stuff. You already know what's coming up. You're gonna have to watch the room. Don't pack. I'm still talking. That is very disrespectful. Don't pack. Put your backpack down. Thank you. You're gonna watch the remaining of the video, and what is coming up will be half angle right here. I'll do the problems before I record them, so I don't make a mistake. And that. All right. So now you guys can pack.
I think we should record those.
Now we're going to move on to example 5, and for this one we're going to use these formulas which are called half angle formula. And they're called half angle because you take an angle, let's call it alpha, and so you divide by 2, so that's like half of the angle. So to answer this question here, we're finding the cosine of this angle. So what we're going to say is we're going to consider the angle alpha over 2 to be what's given to us, so 112.5 degrees. So if that is alpha over 2, then the angle alpha will be 2 times 112.5 degrees. So that one is equal to 225 degrees. And just to remind you where that angle is, it will be 180 degrees and then 45 degrees more. So that would be the angle. Now, what we're going to do is use the formula that you see here. So in this case, we're talking about cosine. We'll be using formula number 2. And this formula will be provided to you, so do not memorize. Now I want you to look at how we have here a plus minus, plus minus, plus minus. So it kind of reminds me of the quadratic formula, but it does not mean that you have both answers. So instead, what it means is that it could be either positive or negative based on the quadrant. And we're pretty good at determining those. Where the sign is positive, where is a negative, and same for cosine and tangent. So what I'm going to be using here will be formula number 2. And so that will be the cosine of 112.5 degrees is the same as the square root of 1 plus, so remember I'm using this formula, so instead of the angle alpha, I'm going to use 225. So it will be 1 plus the cosine of 225, and it's that divided by 2. So now to answer this question, it will be 1 plus, and now the cosine of 225, for this value right here, we could use the reference value of 45 degrees. And so we're very good at determining what is the sine of 45 and the cosine of 45 because they are exactly the same thing. But when we talk about the angle 225 degrees, we have to consider that the terminal side is in quadrant 3. So what that means is that both the sine and the cosine will be negative. So the sine of 225 will be negative square root of 2 over 2. And the cosine of 225 will be also negative square root of 2 over 2. Okay, so now what I'm going to do is substitute right here the cosine of 225 with this quantity here, the negative square root of 2 over 2. And all of that, of course, is going to be divided by 2. Now we're talking about angle 112.5 degrees. So for that angle, it's actually going to be less than 180. So what that tells me is that I can go to 90 and then another 22.5 degrees. So maybe right here. So that angle in green, that is actually alpha over 2, which is the one that we want to find the cosine of. So at that particular quadrant, the cosine should be negative. So because of that, based on this here, we're going to choose to go with the negative sign. So in case you don't know what I'm talking about, we have here plus minus. That doesn't mean that you use both. You have to make a decision either or. So we chose the negative. So just to finish this problem, it will be minus the square root of 1 over 1 minus the square root of 2 over 2, everything divided by 2 over 1. And everything is still inside the radical. So negative square root. Here we're going to have denominator is 1, denominator is 2, so the common denominator will be 2. So the common denominator is 2. 1 over 1 converted to halves will be 2 halves. And then this fraction here already has a 2, so we will just say minus the square root of 2 over 2. For the denominator is 2 over 1. So right here, this will reduce into, we could use the sandwich rule, so we're going to multiply that times 1. So 2 minus the square root of 2 over, and then we multiply 2 times 2, and that will be 4. Now, what this means is that you could take the square root of the numerator and the square root of the denominator. So once you do that, you will end up with that divided by 2. Yes, and that is correct. Now keep in mind that is negative because the angle 112.5 is located, well, the terminal side is located in the second quadrant, and the cosine is negative in that quadrant. So let's move on to the next problem, which is actually an identity that we have to verify. And so what I'm going to do in this case is I'm going to go from the right side to the left side. So let's start with the numerator. So it will be 1 minus, and then the cosine of 2 theta. And so for that, I'm going to use the formula for the cosine of a double angle, but the one that I want to use is the one that contains sine squared. So that's going to be the one that says 1 minus 2 sine square of theta. So what I'm doing is substituting this part right here with this. So then we divide that by the sine of 2 theta, and in this case it will be 2 times sine of theta cosine theta. So now what I'm going to do is go ahead and distribute the negative sign. So it will be 1 negative times 1 will be minus 1. negative times negative 2 sine squared will be positive 2 sine squared theta. All of it divided by 2 sine of theta, cosine of theta. Right here, 1 minus 1 is 0, and so we're left with 2 sine squared theta over 2 sine theta, cosine theta. So right here, 2 divided by 2 is equal to 1, and sine of theta can be canceled with one of the sine squared, one of the sine thetas of the numerator, so we're left with only sine theta on the top and cosine theta on the bottom, and so we know that that one will be equivalent to what we have here, tangent of theta. So now we're going to solve the checkpoint 6 to verify the identity. So again, we're going to start on the right side. So this formula for the sine of 2 theta is equal to 2 sine theta cosine theta over 1 plus the cosine of 2 theta. What I want to get here, since I'm trying to somehow cancel cosine theta, and the reason I know I want to cancel cosine theta is because tangent, by using the quotient identity, we know it is sine of theta over cosine theta. So remember that for this particular double angle, for the cosine of that, we have 3 options. I'm going to list them here. Can I borrow your paper? Okay. So I'm going to list the 3 options that we have here, and we actually derived those 3 in class. The very first one that you guys learned was this. The second one that we derived from the first was this. And the third one that we derived was 1 minus 2 sine squared theta. So what I'm going to do, you'll have to make a decision. And remember, we're trying to end up with something that looks like that. So if you notice, so far we have sine and we have cosine already. So what we want to do is somehow get rid of this cosine here. So it just makes sense that I choose this formula, number 2, because that one only contains cosine. So let's try that out. So instead of cosine of 2 theta, we're going to use this formula here. So that will be 2 cosine squared theta minus 1. And now what we're going to do is just reduce the expression a little bit and see if we can get just tangent theta. So we will have 2 times sine theta cosine theta. We have 1 minus 1 that cancels out. So we end up with 2 cosine squared theta. So right here, 2 divided by 2 is a 1. And we can cancel cosine theta with one of the cosine thetas, and we will have sine theta over cosine theta. And so just to finish this up, this is equivalent to tangent theta, which was what we were trying to do from the beginning. All right, so I'm going to go to the next slide. And so now what we're going to do is take the identity that we verified previously. So example 6, which says tangent of theta is equal to 1 minus cosine of 2 theta over 2, the sine of 2 theta. So that came from example 6. Now I'm going to give you another expression similar to that one, and that was actually the checkpoint that we did, checkpoint 6. So we have tangent of theta is also equivalent to sine of 2 theta over 1 plus the cosine of 2 theta. So now what I want you guys to do is to replace the angle theta, every single theta you see, with alpha over 2. So tangent of alpha over 2 is going to be 1 minus the cosine of 2, and remember we're replacing theta with alpha over 2. On the top and the bottom we'll have sine of 2, and again we'll replace theta with alpha over 2. So we do that, and then you could see what we're getting with this. So it will be 1 minus cosine. Right here, 2 divided by 2 will equal to 1. So we could just say cosine alpha over 2 and 2 equal 1. So this will be sine alpha. And so that is the formula that you will see right here. For the next one, we're going to use the same idea. Replace every theta with alpha over 2. So here we have 2 times alpha over 2 over 1 plus cosine 2 times alpha over 2. So here 2 and 2 is equal to 1. So this will be, bless you, sine of alpha over 1 plus cosine of alpha. And that will be the formula that you see down here. Again, well, not again, but just so you know, there's no need to memorize those. Do not memorize. So far for this lesson, for this section, the only formulas that I do want you to memorize are the double angle formulas. Those are the ones that you will need the most. So slide number 1, I'm going to go back. We had, not number 9, but number 10, we had the formulas. We had the formulas for half angle right here, and the one that we see here is an equivalent, well, actually 2 variations. This formula is here for 2 variations of this one right here. So sometimes it's more convenient to use one rather than the other. And so the very last thing, very last slide, again, we're going to prove 2 identities. And what we're going to do is use the formulas that we have seen here, right here. So I will do both, but I will encourage you to pause the video and try to do the checkpoint 7 before you see the answer. And what I'm going to do is go from the right side to the left side. And I'm going to use the strategy that calls to change everything to sines and cosines. So cosecant, reciprocal of sine, so we can write it as 1 over sine alpha. Cotangent will be, by the quotient identity, will be cosine alpha over sine alpha. Then what we could do here is add both terms, so it will be 1 or subtract 1 over cosine alpha. They both have the same denominator, which is sine alpha. And so by the identity that we had here, or the formula actually, let's see which one. We need the one that has 1 minus cosine alpha on the numerator, so it will be right here, this one. So because of that, we could just say that is equivalent to tangent of alpha over 2. So that's actually what we were trying to prove. Tangent of alpha over 2. Okay, so the very last one, it will be very easy. So please, someone encourage you to pause the video and see if you can do it on your own. So I'm going to use the same strategy, turn everything to sines and cosines. Secant is the reciprocal of cosine, so it will be 1 over cosine alpha. On the bottom, we have secant alpha, so that will be 1 over cosine alpha. For cosecant alpha, we'll have 1 over sine alpha. And then for cosecant alpha, we will have 1 over sine alpha. Okay, so I'm going to multiply a few things here. 1 over cosine alpha over. If I multiply these two fractions here, I'm going to get 1 over cosine alpha sine alpha. And if you notice, the fraction that I have here, it only has sine alpha as the denominator. So if I wanted to have the same denominator as this, it makes sense that I have to multiply the bottom by cosine alpha. But whatever I do to the bottom, I need to do to the top. And that will give me cosine alpha over sine alpha cosine alpha, which we know that is commutative, so it's the exact same thing. So 1 over cosine alpha divided by 1 plus cosine alpha over cosine alpha sine alpha. Okay, now we're going to do the sandwich rule here. So we will have 1 times that. Oh, you're tutoring. Looking at the Okay. So to finish this problem, we're going to use the sandwich rule like I already explained. We multiply 1 times cosine alpha sine alpha, so that will be cosine alpha sine alpha. And then we multiply here the terms in the middle, so that will be cosine alpha times 1 plus cosine alpha. So from here we will get cosine alpha sine alpha. And here I'm going to go ahead and distribute. So cosine alpha times 1 and cosine alpha times cosine alpha. So that will be cosine alpha plus cosine square alpha. Okay, so I made another mistake. But it's an easy one to correct. So I'm just going to erase that. And instead of distributing like I was trying to do here, I'm going to do something a lot easier. So that's just going to be divide cosine alpha by cosine alpha. And that way we will get sine alpha on top. Denominator will be 1 plus cosine alpha. And so if you look at your previous formulas, so let's go 1 slide back. And so we're actually talking about this formula right here. So far we have this on the right side, so I'm going to go ahead and say that that is equivalent to the tangent of alpha over 2. So that's what we were trying to prove. And this is the end of the video.